I was working on this unit and I found something that was fascinating to me. And this is challenging and this video is not critical to your success in this unit, but it is fascinating. So I hope that if you're having a good time in this unit and would like to stretch yourself and try to do something different, that you do. I came up with a pattern that I really, really liked and I didn't know exactly what to do with. So what I ended up working through is I started in my head with the recursive rule, actually. So I defined this recursively, and I said, okay, so my initial term, a sub 0, that can be 1, fine, who cares? And then, from that point on, what I wanted to do is have every term, so a sub k, just be the last term, a sub k minus 1, and I wanted to take that, and the rule I was thinking was double it and add 1. So take a sub k, multiply it by 2, and then take that result and add 1 to it. I feel like I've heard that before, double it and add 1, double it and add 1 as a fun rule to deal with. So I wanted to see what this looks like. Take 1 and then double it and add 1, so that'd be 2 plus 1 is 3. Double that and add 1, so that'd be 3 times 2 is 6, plus 1 is 7. Double it and add 1, so 7 times 2 is 14, that'd be 15. Double it and add 1, that'd be 30 plus 1, so 31. Double it and add 1, that'd be 62, so 63. I'm going to keep going with this because I actually really like this. Double it and add 1, that'd be 126 plus 1 is 127. Double it and add 1, that's 254 plus 1 is 5. And this will go on infinitely. If I were to just present this series of numbers, figuring out that the pattern was double it and add 1 would actually be really tricky. And I've tested this out with a couple of students, and we've struggled to figure it out. That said, there's actually a different way to define it. And I'm really interested to see if anyone can come up with a explicit definition of this sequence that is based on something, yeah, this is your only hint. It is based on something that I have seen you all do in computer science and that I've seen you do really well. So, that's all I'm giving you, because I will give the grandest of high fives to anyone who's able to figure this out. All right.